Okay, hi everyone. Welcome to our first CSG meeting. Thank you for coming. My name is Charles. I'm the president, and I'm just gonna. Thank you. Thank you very much. Okay, so yeah, if you haven't signed in, please sign in. You need to do it if you want to get food. And let's just go through it. Is this still OBS? That is still OBS. Oh my gosh. Oh, over here. Okay. So what is CSG? Well, we're the computer security group. We give weekly talks about various cybersecurity things. This time on Wednesdays, obviously, because you're all here. And the first Wednesday of every month, we go to the Dallas Hackers Association. It's just a little group of 30 to 40 professionals around the Dallas area who just talk about what they're working on. It's really cool. You should definitely try it at least once. If it haven't, they've canceled for the past 2 months because of COVID, so we're not sure if it's going to happen in March. Actually, Peyton, you should talk about SFS because you're in it.
I'm going to please Dr. Sirach and shill my scholarship. It's scholarship for service. It's mainly aimed at graduate fast track and PhD students. And essentially, if you want to go to grad school and you want it paid for and you want to get paid $20,000 to $30,000 a year, you should do this. The only stipulation is that you work for the government for 2 to 3 years afterwards. But usually you get opportunities at places like NSA, CIA, FBI, national laboratories. So if you're willing to do that and you think those are really good and you're more interested in working in the government field where you could work with large agencies like that, then go ahead and consider SFS. You can find the website at just Googling UTD SFS or going to the link at the bottom there. I believe they're going to start accepting applications around April is when they normally start doing it. So be lookout on your email as well for any emails that are talking about SFS if you're interested in that and if you're going to be a grad student or a fast track student.
Okay, so let's introduce the team. And thank you, Peyton. Again, I'm Charles. I'm the president. See everyone on the Discord. Next, we've got Jerry. Jerry, raise your hand, please. So everyone say hi to Jerry. Let's clap. Jerry's the vice president. We got Vishvak over here. He's the secretary. Yeah. Let's do a round of applause for everyone. Peyton right here, guy who just spoke, treasurer. And we have Lath, who was the president last semester. Suraj is over there. Tala, where'd Tala go? Right there in front of me. There's Tala. Elliot. And is Kai here? No? And Segev, who I've never met. So we should update the slide or something. I don't know. So yeah, we've got 2 faculty advisors, Dr. Sirach and Dr. G. A lot of the officers will talk about taking Dr. G's class and shilling for it because he tells them to talk about it. If you don't know how to join, I'm surprised you got here, but you can sign this. You can scan this QR code to join the Discord, and that's all you need to do. There's no dues or anything. We're very laid back. Again, we do weekly tech talks, Wednesdays at 7. Oh yeah, and this is what we're going to be talking about this semester probably. Embedded systems, Python and PyJails, which I'm giving next week. Today is anonymity, game hacking, and fuzzing. And if you want to see something that we haven't listed, tell someone and we'll consider it. There's usually 1 corporate talk per semester. This semester it's Paycom. Paycom is going to be the first or the second week of March. And I forget what I asked them to talk about, but it's going to be lots of cool stuff that all the other officers think are cool also. So you should definitely join that. That's going to be remote, I think, right? Usually remote?
Kind of depends. They might send recruiters down.
Okay, we'll see what happens. We do fire talks once a semester, or we try to. So if you have something cool that you are working on or have worked on, and it really doesn't even have to be completely about security. Scan this QR code or go to this link, and you can sign up to give a short 5 to 10 minute talk about it. It's a cool way to get some visibility on your cool project that you're doing. Last semester we didn't get any submissions, so we're going to be pumping it real hard this semester. Every Tech Talk you're going to hear about this. Sign up for Fire Talks. Resume, you can say you talked, you gave a talk. That's great for your resume. Any questions before we go on to the actual Tech Talk? Going once, going twice. Nope. Okay. Well, here we go. Giving it up to Elliot and Vishvak.
I'll just mess with that then. What's the time? Okay. Hello, everyone. For today's Tech Talk tonight, we're just going to be basically doing some basic talk about privacy and anonymity. I'm going to be messing up that word all of tonight, so it is what it is. So we're not going to go too deep into specific, like, code or anything like that. Like, this is going to be pretty general concepts, but should give you a good idea of some cool stuff. So, right. So, basically, first we're just going to start off. This is a really simplified general diagram of what it's sort of like when you're accessing a website or a web service. So, I'm just going to sort of go through different parts of this, talk about some privacy concerns, some security concerns that can arise in this process, and also ways that you can protect yourself, or not protect yourself, but use it against other people, I guess. Yeah, so again, this is oversimplified, but if you're the client over there on the left, trying to get to whatever web destination, you're going to be talking to your ISP. Your ISP is going to have either its own DNS server or talking to a different DNS server, depending on your configuration, whatever. And then it's also going to be talking to whatever your destination is. Again, it's like way simplified, but right. So first we'll talk about sort of more focused on the individual security, things that you can change personally quite easily to help protect yourself. So first, I'm going to do just a little bit of a talk about cookie basics. So I'm sure a lot of you have heard of cookies. If you don't already know exactly what they are, probably better than I do, to be honest. But for that, I would say I have just a kind of explanation here of what it would look like. So if you're the client, and let's say you're visiting cats.com, as we all do, you would say, I would like to see, you're sending a request, I would like to see your finest webpage of blue kittens, please. Okay. Cats.com is going to reply to you with that web page. As you can see, there's those blue kittens, Russian blue kittens right there. And it's also, if it decides to, it's going to serve you some cookies. Right here we have cookies number 1337. Your browser, especially if you're using Chrome, Firefox, is going to take that and then just store it on your browser, on your computer, so you can save it. Right? So imagine this is your first time talking to Cats.com, requesting a web page. So after that, let's say this is the next day, and you're like, wow, I love that website, Cats.com, I'm going to go back. So you're returning back, you're saying, I would like to visit the home page maybe. Maybe this time you're not specifically asking for blue kittens, you're just going to the home page. In the header of that request, it'll have some information about those cookies. Might have cookie number 1337. Cats.com is going to remember, oh, I remember cookie number 1337. He really liked the blue kittens. So when they send you that home page, they're going to maybe add some blue kittens already in there. And I don't know, maybe you'll like the website better or something. So here I just briefly put, this would be what actually sets your cookie. You can see in this red circle it says set cookie has, for example, here's just a name. It says name is Alice, age 30. So that's sort of you can imagine what some of that might be in a cookie. And it's also, most of them are used for persistence, so maybe keeping track of like what's in your shopping cart if you're doing online shopping. And it also might be doing stuff like session persistence, like if you're changing the color scheme on your search engine or whatever that is. When you go back to that same search engine, you'll reserve that color scheme from that cookie that you set. So that all sounds like pretty good, to be honest, right? But how can cookies be a bad thing? How can it not be great for privacy? So cookies, there's two different types, like overgeneralizing them, but third-party cookies, first-party cookies. So first-party cookies would be the cookies that cats.com gives me, and then when I go back to cats.com, it's like an interaction only with cats.com. So that, again, could be like, oh, I like the dark theme of cats.com, so when I return, it's that. But at the same time, it could also be used by other websites. So like super cookies, where it's used for advertising purposes, tracking what your usage is online. Oh, this person really likes blue kittens. You go to Amazon and it tries to sell you some blue kittens, that type of thing. So again, it's sort of, this is where we start talking a little bit more about like threat models. So if you don't have an issue with a company profiling you, saying, okay, I know this user does this, and this, you might, not really care about that. But if you have a very strong like privacy mindset, this is where you might start to not want to deal with cookies, especially third-party cookies. So at that point, pretty much like any browser you use, you can turn off third-party cookies. You can also turn off like all cookies, but that'll like break pretty much any website you go to. So not really a good idea. But turning off third-party cookies can be a good way to sort of block that like entry-level tracking. Yes. So another way it can track you, so we talked about cookies, which is sort of its own like built-in thing to do some type of tracking or persistence, right? But there's sort of almost like, you can imagine it as a hidden cookie as well, which is fingerprinting. So that is finding, a website is going to take as much data as it can like about the client that's accessing it to then say, okay, how can I differentiate this person from other clients based on that data that I acquire? So for example, some of the things that it can ask for, but also sort of determine, is the canvas size here. That's like how big your browser is. You can also find out stuff like your operating system architecture, RAM. And then if you're using JavaScript, among other things, it can track your location. It can geolocate the user. So if you imagine, and sorry for the quality of this stuff, I don't know what happened to it. I had it easy, but if I have all this data about a certain user, and I see, this is an example of all the data that it can get from the client about like sort of what their browser settings are, different factors about that person. You can see how you can sort of, maybe not specifically identify an individual person, but you can narrow it down by a ton. Like if someone accesses your website and is, I don't know, their canvas size is 1080 by 791, that's sort of weird. And then so that you see that reoccurring, you can kind of know that, well, most people aren't using that canvas size. Maybe this person has like a preset, I don't know, window size they're using. So that's sort of another thing that starts to be used to differentiate you from other users. So again, more talking about what is your threat model, like what do you care about? So in this case, right, if you're really, really sensitive about, I do not want like anyone knowing what I'm doing online, which of course none of us would do, but just for example, you would want to make sure that you're not able to be fingerprinted in this type of way. Here, actually, I'll add one more thing. And also, we're talking about, before I was talking about the cookies, and in your browser settings, you can turn off third-party cookies. For fingerprinting, there's not like a ton that you can do other than switching to a better browser like Firefox has like pretty decent fingerprinting or like anti-fingerprinting stuff, or using like a modified Firefox, so like LibreWolf, or like the custom, different custom Firefox things you can use. But then that's where you're also going to like super far into privacy. You can cover this one.
So I guess the next part of this, as you saw from that graph, would be like the ISPs and the DNS, right? So we've sort of talked about how you can be identified like just by using your computer, but the real question that also comes up a lot is how, where you're sending your network traffic, right? Like where does this go after your Wi-Fi router or after, the school's Wi-Fi router? And the answer is the ISP and a DNS server. So as Elliot explained, right? So when you make a request, your ISP gets the request forwarded to it. So like the router will forward the request to your ISP. And that's when your ISP needs to connect you to the website, in this case, cats.com. So the ISP will ask the DNS server, how can I connect to cats.com? And the DNS server will reply with the IP address of cats.com and send that back to the ISP, which sends that back to you, and that's how you get like the website basically. So in this case, you have you know what website you're connecting to, your ISP knows what website you're connecting to, and your DNS also knows what website you're connecting to, along with the website. So there's a lot of different places where that data can be stored, collected, stolen, logged, anything. So the big problem here is really that like the ISP and the DNS both will log your data. So in the United States at least, ISPs are almost always like going to be big multinational companies with a vested interest in taking your data and selling it. So most of the time, they'll log your IP address, what website you're going to, they'll log your MAC address, like as much data as they can, and associate you with like certain websites, certain content online. So that way they can sell that data back to maybe an advertiser, maybe, I don't know, like there's various people who want that data, and ISPs are one of the sources of a lot of this data as well. So along with that, the DNS server, which is sometimes run by the ISP, sometimes there's a separate company that runs the DNS server, they maintain the same logs as well. So in this case, all of these logs are stored forever, and they're used to build specific profiles on you, so that way ISPs and other people can know, your spending habits, your online habits, etc. And mostly they can use it to sell it off to advertisers. So one way to solve this problem is the DNS, right? So you obviously only have a couple options with your ISP. Like I'm pretty sure most of Dallas, it's basically just like Comcast. But you can change your DNS server. So a lot of, I guess, in your browser settings, you can change the default DNS server that's used to get the IP address of certain websites, right? So in this case, a lot of privacy-oriented companies, a lot of community like organizations, open source organizations have their own DNS servers that run. For example, Cloudflare runs some. I know Google runs some. They say it's private, but it's probably not. Like in this case, that's what 1.1.1 is. I believe that's the Cloudflare DNS that a lot of people have started to use, and that's sort of slowly becoming the standard for a lot of privacy-oriented people. Along with that, Cloudflare, in this case, I guess for the example Cloudflare, they don't store logs, they don't store your IP address, they just store, like general aggregate data to improve their platform, but they don't store anything that can connect back to you, and that's why a lot of people like it. So that basically means they don't sell it for advertising, they're just doing this because they like privacy.
Yeah, and then I'll add something to that too. So before I say this, I'll preface it by saying your phone is like the worst privacy thing ever. Like it's basically a joke to like care about privacy, but then also own a phone. But here we are. Of course, I'm joking. I mean, there's no way you'd like throw away your phone to be more private. But here we have, it's sort of the Cloudflare 1.1.1, and then Quad 9. But another thing that DNS servers can provide, especially if you can set your custom DNS in your browser, but you can also set it system-wide for it all to be resolved through a certain DNS server. So you can also do this on your phone, for example. And through doing that, you can do like network level blocking of trackers. So this isn't a catch-all, but it can work pretty well. If I'm using NextDNS as an example of a company that does this. So, for example, if I'm visiting cats.com again, then let's say when I'm visiting cats.com, cats.com requires me to also visit cdn.cats.com, and also they have some tracking domain they're using for maybe some like plugin or something from tracking.io. When that request goes to NextDNS, they're going to see, okay, yeah, we can resolve cats.com, we can resolve cdn.cats.com, but once it sees tracking.io, that might be on their like master list. They'll have a master list of just tracking domains. You can also set your own custom ones. You can use, like, people post just big lists on GitHub. You can use those. And it will block that domain from being resolved. So stuff like background check, like especially Instagram and Facebook, that type of stuff, tracking in the background, analytics. It can, if you set that on your phone, for example, it'll be blocking that in the background at a network level. Like, you don't have to mess with it on your own phone or your own device. So that's just something else to add with. Another way it can not only secure yourself, as in separating from the DNS that logs all your stuff, but it has an additional feature which can be blocking trackers in that way.
So another way to do this is obviously, like, I mean, most people know what a VPN is, but a VPN, I guess for those who don't know, it's a way to, it's like a proxy server for all of your traffic, right? So instead of sending your traffic directly to a DNS or to your like ISP, right, you first go from your laptop or phone to like the router, and then the router sends everything to a server that you run or a trusted entity runs, for example, and that would be the VPN. So the VPN would then forward all of that data to the ISP, get the like website, and then send that back to you. So you're basically like running everything through a second server that you aren't really affiliated with in any way, that has like none of your information affiliated with it. And that's a way for you to privately browse online instead of having to instead of having to just like expose your IP address, your MAC address, etc. So the VPN helps, but it's not like a catch-all for anything privacy related.
Yeah. And another important thing that you said is it doesn't contain any of your like personal information, but if you're paying like NordVPN with your PayPal, then like I don't know what, and they log, so it's like I don't know, that's not as much.
And the big thing you have like when you're looking at like a VPN provider, right, is that a lot of VPN providers still log your data, and they're able to associate it back with you because of, say, you make your account with your real name, or you make your account with your credit card, right? That's very easily associated back to your name. So a lot of VPN companies still log, still associate stuff back to you. They just claim they're private. So you have to find a good VPN. And there's very few of those good VPNs, because then it's really hard to make money. So that's why a lot of the more expensive VPNs are actually the better VPNs for privacy. But yeah.
You can go to Micro Center and buy gift cards with cash
that too.
for some
Yes.
VPNs. So
Yeah, you can also, I think it's Molvad you can like mail cash to. I think that's one of the things they like to do. You can like mail them just a envelope, which I don't know if that's the best. Or crypto. They're like Molvad takes crypto.
yeah, most take crypto.
Yeah, some take crypto. So and Monero. But
So, I mean, the last thing here is also just your VPN isn't like a catch-all, right? Like the government can still force some VPNs to give the data to them, right? Just different things like that. Some VPNs, like through a court case, right, they've been forced to give out that data, and some VPNs legitimately don't have the data, and like the government has audited them and they don't have it. So it just really depends, like which service you use. You just sort of have to do your own research and pick something that you're comfortable using. yeah, so I mean, the next part is really Tor. Everyone's heard, most people have heard about Tor, often associated with the deep web, different concepts like that are associated with privacy, right? But Tor is generally, you can consider it as a way to access, like, I would say it's a way to, it's one, like, a more privacy-oriented browser in some way, but it's also a way to access specific websites, specific content that you can't access from, like, a normal browser like Chrome.
Yeah.
So,
Has anyone not heard of Tor here? If you raise your hand, that's a good thing, by the way. Is that only one? Okay. 2? Good. 3, 4?
yeah.
Perfect, perfect.
The way Tor works is that instead of, like Chrome, for example, Firefox, for example, they'll run everything through Mozilla's or Google servers. In this case, with Tor runs everything to a distributed system of servers that no one really controls, allegedly. That's something for later as well. But according to the developers of Tor, a lot of people you talk to, they'll say the systems behind Tor are distributed, so no one person can really see what you're doing or sees all of the data that you're transporting, which is what this slide sort of shows.
Yeah, because Tor has really strong, like very, very strong encryption, but when we're talking in more of that privacy and anonymity like standpoint and view of Tor, while we can get pretty good, like just imagine, if you're imagining this as standalone, right? Like it's really good. How it works is the desktop here, the client, has their message, and they're going to encrypt it in like 3 different layers. And as it goes through the network, those layers are basically peeled off, those layers of encryption, the onion router, that's why it's called that. So once it gets to that exit node and goes to the destination, it's just really hard to tell like where did that initial message come from, and then it does the same process backwards to return. And the client will then get a full onion back and then decrypt all the layers. So, but as Vishwak was saying, that's only good if all the nodes are controlled by like not one person.
Yeah. So generally, how this works is you want, I guess Tor is sort of seen like the network is sort of seen as community run, right? So it's just people. It's sort of like crypto, but I hate comparing it to crypto. So it's distributed and it's run so that way no one person is supposed. There's supposed to be enough compute power in the system so that way no one person runs more than like 50% of the system. But that's really something that you can't, like check or verify because anybody can add their own compute power to the Tor network. So I guess some very, very privacy-oriented people, I guess like basically people who are scared that like the CIA has their hands in everything, they think that the CIA runs like half of the Tor network, so they still get all of the traffic that runs through the Tor network. But that's like borderline conspiracy theory, if you ask some people, right? So it's really how comfortable you are, right? Like, do you really believe that the Tor network is distributed and anybody, and like, one person doesn't control like the entry or the exit, right? Then Tor is something you should be comfortable using. But a lot of people don't, and they take like much more aggressive measures.
Mm-hmm. And does anyone know like the big down? So like Tor, this alone, it seems great, right? But some of y'all probably know this, but the like big downside for Tor, especially if you're using it like daily. Come on, yes. Slow, exactly right. Yeah, these nodes are like worldwide. So if you're using this on your phone daily, you're gonna be like waiting at the bus stop trying to look at the schedule, and it's it's going to take like 30 minutes to check the schedule. No, okay, that's an exaggeration. Probably take like 2 minutes compared to like 30 seconds. But anyway. Oh yeah, and this diagram is just trying to show, you can imagine if this hacker man has the exit and the entry, or you could imagine it as maybe someone just sniffing the packets, not like in control of the nodes. they can do sort of like what's called like a tempo, or I don't know the like real name, but like a tempo analysis or like a timing analysis of it. Temporal analysis, or where you can basically like track. Can you explain it well?
So basically, you see how much data is going through the exit node, and the exit node is unencrypted, so you can see what's going on there. So if you're monitoring that, and you say, oh, they just sent a 4 megabyte file over this, and then I see, however many seconds later, oh look, that 4 megabyte file just came out of this entry node. I don't know what the file is, but I can draw some conclusions that it's probably the same file.
Yeah. So you can imagine it almost like if you had a graph of like, okay, when are these packets showing up? What size are they? Blah blah blah. And then you're matching that from the entry to the exit, or the other way, exit to entry. Then you can start to figure out like, okay, well, who's this person that's accessing this website? Again, that's kind of like where you're starting to go crazy if you're worrying about that. But if you're like really worrying about privacy, then
some of the 3-letter agencies have tracked people down with that. So
yes.
Don't do illegal stuff. My best advice.
So another aspect of this is like virtual machines. Do you want to?
Yeah, I can talk about this too. Yeah. So anyway, I'm going to just tie this into Tor in a second too. But yeah, as I said, don't do illegal things. But with virtual machines, I'm sure a lot of you have at least heard that word. It's can be something in the cloud. It can be something on your host, on your laptop, whatever. This is just a little small diagram to generally explain what it is. So right here, big blue box, physical hardware. So yeah, I don't have to explain it. Your host operating system. And then under that, you can install basically virtualized, operating systems beneath that. So almost like emulating, a lot of you also have heard video game emulation. It's almost like emulating that operating system in your own operating system. So what that allows you to do, if you're thinking back to fingerprinting, for example, it's going to be separating you quite far from whatever your host laptop is, right? But this also, if you have a virtual machine, that by itself is like, you don't install a virtual machine and you're like, okay, I'm private forever now. No, because you're still going to be accessing that on its own. It's just going to be accessing through your normal ISP, and you can easily get tracked that way. But you can tie that into this next thing. So there is a solution called Wonix. This is probably like 90% illegal things, to be honest, people using this. But, well, I'm guessing that. But basically, it's 2 virtual machines that you install that sort of talk together. There's the workstation and then the gateway. So the workstation, it basically like talks to the gateway, and the gateway connects through Tor. So all of the workstation's network traffic is put through Tor, but as long as it's supported, and that won't leak your IP, like your host IP address. It contains some really cool features. We were talking about fingerprinting. You can fingerprint based on the tempo of your typing, right? That type of thing. This has a way to counter that. It is supposed to anonymize your typing by messing with the timing or something. So it has those sort of elements in it, as well as it being a virtual machine, to try and make it as secure as possible. Again, this alone is pretty secure, but you shouldn't really have to be doing this, to be honest. But I'm watching y'all. If I see Wonix on your computer, I'm gonna be a little weirded out. But I think, that's about the end. But I did add some just fun things that you can get tracked with. So yeah, you can see some of these here. Some general fingerprinting techniques. Some of these are kind of wild. So analyzing text linguistics, I know a lot of y'all are on social media too. If you're posting a ton of just like rants on social media, your almost like style of writing, your style of speech can be, I'm going to say fingerprinted, which doesn't really help, but almost like analyzing. You can find those like nuances in your language, and then that can be matched later if you post a paragraph on, I don't know, like sellingdrugs.onion. So that's, one thing. Similar, I was talking about the keystroke pacing and pattern analysis, so it's analyzing how you type, especially if you have JavaScript. It's a lot easier to do that if you're JavaScript enabled. It can even happen with mouse movement. It can sort of track your mouse movement and that sort like pacing, and even if your mouse like has a little bit of a weird way it moves, that can also be used to help differentiate. Something else, if we had more time, probably talk about file metadata, which is sort of its whole own thing. But for example, when you take a picture with your phone, on its own, it's going to be taking just a ton of data with it. For example, like the physical location that photo was taken. So if you a lot of services are going to take that data away, but some of them won't. And you share that, people can look at the metadata in that photo and be like, okay, this person took this photo at UT Dallas or whatever. And then we already talked a little bit about that packet timing template analysis thing. And then I guess this is a shout out to the SFS scholarship or something, but the Fed the Fed toolkit. Here is just some things that Feds can do, but facial iris and tattoo recognition. That's kind of self-explanatory. There's also stingrays. There's other names for them too. I don't know enough about them, but they basically mimic a cell phone tower, especially used in like a situation with a lot, like maybe a riot going on, that sort of thing. And it will almost like relay that cell information and then get as much information from that as it can. And then there's something called Section 702, which came from 2008 era, which is basically just a lot of I'll take your data, thank you.
Yeah.
From companies and individuals, sort of. So you want to add to that? The Section
just
702.
to add to it a little bit, the facial recognition stuff, a lot of the countermeasures that people use, for example, like obviously, a camera is needed. So some people like wear like a hat with a little like, what is it? It's I forget the name. Sorry? Yeah, the infrared light on it, right? Okay. And it blocks the camera because cameras can't see infrared light. And in a lot of places, like you can get in trouble for like having one of those. Some people wear like shirts and stuff with like people's faces printed on them. Those are also something you can get arrested for having. Different things like that. Recently, it's become possible to like track how you walk. Like just literally like how specific, like how you walk is different for everybody, obviously. And then if you add that in with data like how tall the person is, which can be just figured out by math because your shadow exists, you can basically figure out like who a person is, right? So a lot of people like just put a lock in their shoe or like walk weird. It's really stupid, but like the more like crazy privacy oriented people do that. The stingray stuff is like it's almost unavoidable. Because they can literally just put a fake cell tower somewhere and run all your data would be run through the fake cell tower before going to like a web server or something, right? So a lot of the time people will just buy like a burner phone with cache or something and like only use it on like specific Wi-Fi networks, just random stuff like that. Like a lot of people who are more on the like crazy side of this like do that. The Section 702 stuff is also really interesting because there were a lot of leaks, if you remember the Edward Snowden stuff. A lot of that leaked, and a lot of what people learned from that was that like basically when you send stuff to like a DNS or like a ISP, right, like we talked about earlier in the talk, there's like a place where that data is like copied, and the copy of the data is just like sent to the NSA directly, like within like a cabinet, like in the server room, right? So there's really like literally nothing you can do about it, and it's like a physical link that they have. So a lot of the time, like when people talk about Section 702, it's literally like the government, like looking over your shoulder, like doing its best to look over your shoulder, and you're really just trying to avoid that.
Yeah. Like AT&T literally had, I was reading about this for this, but you can imagine like the physical fiber optic cables they had. They literally split it. One went to AT&T and the other was like to the NSA building. And they would literally just take everything, all, I mean, take that as you would like, Yeah, so I guess TLDR is shout out SFS scholarship. And if you want to be a...
Can't beat 'em, join 'em.
Exactly, yes. So if you want to be looking at a lot of random people's data, then that might be for you. No, I'm joking. But and sort of to wrap it up, because this is basically about the end, but with when we're talking about privacy and anonymity, online. With a lot, same thing as it is with a lot of like computer security things. It's basically as strong as your weakest link. So if I'm using the Tor network, first off, my ISP is going to know that I'm using Tor in the first place, unless you do some other stuff. But anyway, and if you're not properly protecting yourself against fingerprinting, then that's another way you can get de-anonymized. So yeah, it's basically just privacy in general is how, when we're talking online, is what is your strongest, weakest link, and is it worth going through the process of using all of these different applications to protect yourself, especially when it leads to a lot of downsides. Like if you're using a hardened browser, shopping on Amazon is going to be like so difficult. Like I noticed. Amazon doesn't work on my phone because I use a custom DNS. So maybe I'm just mad at that. But
we should all write our own custom encryption schemes and run all of our web traffic through it. And that way they can't break the law.
That's a good idea.
Really good.
Really good.
Not worth their time.
Yeah. All right. Yeah, so that about wraps it up. Does anyone have questions, comments, concerns? Was the pizza bad? No? Good.
Get more.
Yeah, get more. Yes, take the pizza. But no questions, nothing else? Anyone want to admit they use Wanix?
We had an officer that used cubes religiously, and we bullied him a lot for it. But that's what Snowden uses. It's very similar.
Okay. Well, thanks everyone for coming. And thank you, Vishvak, and everyone, all the other officers here today. Anyway, take pizza, everyone.
I'm going to end the stream.
Good talk, y'all.
All right.